Is that better? Okay. Anyway, well, good afternoon, everybody. Thank you for coming to this session. Welcome to All Change session. We're going to hear about the new GN3 or GÉANT project from a couple of our speakers, and also from Steve Cotter on the new ESNet architecture, hybrid architecture. So there's a lot of changes happening, research and education networking, both sides of the Atlantic, so we'll hear from the speakers on that today. But first of all, we'll have two presentations that will look at the new GÉANT project, which operates the GÉANT network. But it's also got a key focus now on developing and rolling out applications and services to run on the network so that users can make the most of the bandwidth and the reach of the network in their research and collaborations. Then we'll look at the US Department of Energy network, so ESNet, and how it's responded to changing needs with a new hybrid network architecture. So first of all, I want to welcome Hans Dobling, who will come up in a minute. He's the Joint General Manager for Dante and the Project Manager for the new GÉANT project. He was also Project Manager for GÉANT 2, the predecessor project. He's got a background as an experimental physicist, and amongst the places he worked was CERN, that we all know about. And he was also in IT services, including time at the European Molecular Biology Laboratory in Heidelberg. Hans is going to describe the GÉANT project, give us an overview of the objectives, the plans, and the activities of the project. So I'd like to welcome him.
Those of you that have looked at the portal will have seen, among others, a podcast from Dorte Olesen, outgoing president of Terena, that has sort of had about a term of service for Terena, like was the predecessor project, GÉANT 2. And among the things that she sort of says, looking back, is that she enjoyed the development of the project and of the community of NRENs in this period. And I have a way to illustrate that for you. And that is, if you look what the main themes of the sequence of European networking projects were, if you look at those, you have in the GÉANT project bringing into 10 gig connectivity on a pan-European scale. And in the GÉANT 2 project, actually moving into this so-called hybrid era where you would use the techniques that the carriers used, the dark fiber, and light it yourself. And to measure that, what we've done is looking at at the end of GÉANT 1, we are showing you here where in August 2004, 10 gigabit capacity was available for research and education. And you see in the straight lines, the backbones Nordonet and GÉANT. And then you also see some of the countries already had a bit of 10 gig infrastructure at that time. And some had something that is drawn in here in red. And these were sort of the leaders. They had fiber already at this point in time. And now looking back of what has happened over these last 4.5 years that Dorte has been looking at, and then this situation looks now like this. Yeah? That's a huge change that has happened through the combined effort of the partners. So we are not everywhere yet, but we have made a big step. This is just to show you the well-known topology, because this thing doesn't show everybody connected. We have services for Cyprus, for Iceland, for Malta and Israel. So this actually shows the full European partners connectivity, which you will know. Now, what is going to come in GN3? What are we doing different? One aim is to actually expand the reach to cover the full European geography ultimately. That is done moderately. I mean, there are 3 new members. The NRENs of Serbia, Macedonia, and Montenegro, AMRES, MANET, and EMREN, are becoming full members of the project. And the networks in Belarus, Ukraine, and Moldova, which are BASNet, Uran, and Renam, are becoming special members of the project. So this is the step in enlarging the service area which is planned for the project. The second goal is actually to enlarge the global collaboration. This is again a very well-known picture that I'm showing here, which, if you decipher the color code, tells you that transatlantic there is a lot of 10 gig capabilities at the moment between the North American networks and GÉANT. In other world areas, there are quite a lot of connections to the EU funded support projects in Southeast Asia, Latin America, and the South Mediterranean, to India, to the Black Sea countries. This is going to grow, and we are trying to deepen the collaboration with other world regions. A very good form of this collaboration is DICE across the North Atlantic between North American entrants and GÉANT, and that is recognized again as a very formal tool now as part of the project work to continue that, and we may want to look at other world regions to do a similar collaboration. And that means actually adapting your services and adapting your operations. It's about this safe operations and service. Next goal is actually to expand the customer base. So far the success stories are concentrating around high energy physics, radio astronomy, and high performance computing, at least as far as sort of those novel circuit services are concerned. There are a lot more potential customers there. There's a whole catalog of S3 projects for non-European people. This is a sort of a council that recommends research infrastructures, and they have a wide range of ships or airplanes or certain infrastructures that are needed for research, fusion research. Earth observation is another field, climatology, the life sciences, which are now dealing with amounts of data that are approaching the ones from high energy physics, a distributed European Institute of Technology, the arts and humanities, and many others that I haven't put here. We want to make an active move to widen the usefulness of this research networking pan-European and actually make it a hub for global networking, and make the combined effort of the partners into a dependable service layer in the e-infrastructures architecture and serving the research, the researchers and the education in Europe and worldwide. And doing that, it is important to notice that a lot of those research organizations take, for example, ITER, or take the way that molecular biology data are exchanged between 3-4 big world regions. These are multinational or globally organized, and they have an expectation that they also get a European or a large picture, and they're getting offers for networks on a large scale. So GÉANT will be able to do that. The motto of GÉANT is actually, of GÉANT3, is actually this service area where all the partners contribute to service, agree on service concepts and contribute to them. And these services are grouped in 3 different areas, which are just in project speak. These are service activities. They're mapped to that 1, 2, and 3. And the first one, the core, is actually the backbone network with the global links, serving the 36 European partners, NREN partners. Around that, you could see a layer of multi-domain connectivity services, IP, circuits, wavelength, basically serving the big science users, the campuses, or with connectivity. And around that, and there you talk about thousands of potential customers in Europe, or multiples of thousands. And around that, there are services that are directed at the academic end user. And these are mainly to do with identity and roaming and remote access. Tools that we want to build to enable virtual organizations like we ourselves actually are one, and we are a good example whether we can use such tools or not. Service is the GÉANT service area is this motto. We see a change here in going from a technology-driven way that we worked in GÉANT. We said, okay, we do a little bit of research and development in some interesting areas and see what comes off it, and then transit that to service. The approach now is to say, what among all those 36 partners could crystallize out as a service concept, well-defined, well-described, and then how do we implement it? We put the development work in there afterwards. And we have a commitment to do this, and we have an analysis before whether there is a business case for that service beforehand. And therefore, this is truly a change in the approach in the project management in GÉANT. The business case will be very operations aware, and in fact, from bottom up came many of the engineers in the project are actually sort of ITIL fans, and they use that set of tools. You can use common sense as well, or good other business practice and development practice, but this is what is actually being used for the continuous change and improvement of a service. I will very quickly just show a example, not necessarily ideal and not necessarily 2013, service portfolio of the services that are there. And again, you recognize on the left sort of the connectivity type of services. So possibly what the most unusual among them would be a multiple VPN, managed VPN service possibly. There are these in the Earth observation and meteorology. There are a lot of people that want private and deterministic networks, but with very low capacity. They want those managed, and this may be a reaction that we follow after a good analysis of what is done. There are operation support services, and there are the roaming and AI services. I will not do more detail. Aphrodite in the talk afterwards will do a lot about the services there. And I'll jump into the project characteristics. In fact, here it's all the same as last time almost. The total budget, at least for the first two lines, the total budget is 182 million euros over the 4 years. Thereof, about 51% will be funded by the EC. We have 38 project partners, the 36 NRENs, about who it is, all Terena and Dante. And Dante is the coordinator of the project. The project, the main cost still with this is actually operating that backbone and operating the global links. But the development work, the manpower cost has grown relatively to previous. We have now about 500 person years over 4 years, or in other words, if we were very focused, we would have 125 people organization for 4 years. Yeah? And we are somewhere below that with our efficiency and with our fragmentation, but we have quite a big workforce available in this. 450 individuals have registered to date, roughly, on the project portal. We actually speak without having a signed grant contract, and we have actually, if you show the work progress, we've actually worked already for quite a while without a signed grant contract, but I also heard yesterday's talk by Kostas Klinos that was very positive, and so we just have confidence in our future. If that future is, which I believe, it'll be backdated to the 1st of April 2009, and then go from there for 4 years. In the management, the challenges will be actually in building a distributed virtual team that is at the same time flexible and efficient. That will be a big challenge to get a real organization, a common organization feeling among those that are working in this project. This slide sort of shows the governance. There is a big change. Prior to that, we sort of had a technical committee. Now we really have a project management committee that doesn't just look at the technical side, but looks at the networking and at the service management side equally well. And we also introduced a much stronger project office to do the horizontal tasks. There's a policy committee that, as we had before, with delegates from the partners that vote, and there's a board that governs the project, and then there are the executives and the actual activity leaders and task leaders in this structure, in this project management team. The upper 3 layers there are sort of regulated by this, by something called the consortium agreement that has to be signed yet, and that regulates the interaction between the partners. That's the project structure. I think Aphrodite has a lot about that, and these are the activities. The only thing I would like to say is that we found it very important that the corresponding development activities or research activities match the service activities, so that there's a pairing of those that is important for us. Something that hasn't shown on the other thing is software governance and the software development environment as a service internally to the project, and as a means of also getting a common software governance and policies into the work there, and ensuring that the products that we develop are actually maintainable afterwards. For your perusal after this, the list of names of the activity leaders and project managers, which are Di Davis and myself from Dante. And I'd like to point at the 2 big activities here, SA2 and SA3, which are both led by Anne Harding actually, and by Josh Howlett from our NREN partners. So these multi-domain services and the end-user directed services are directly shaped by NREN partners, and I think that's also an important message that we give about this project. Our challenges, we have still a lot of regional differences in market development, and we have a geographic divide in Europe, and we have a historical divide in Europe that isn't fully overcome. So that creates differences in the areas that create to different interests, that lead to different interests, and we have to overcome those. We have managed to do that in the past, and I'm confident that we will be managing to do that in this case as well. Getting common service concepts in the GÉANT service area. This is these 36, or a subset of those, actually on agreeing that for us all, a recognizable service is the following. Yeah? That will be a difficult thing to do, where implementation and technology are mixed with service concepts. Again, that's something we will have to deliver on. Balancing between service delivery and continuous innovation will be something difficult. You always want to have the latest development included. You want to follow other developments, so you continuously work on your products. Shaping the new architecture, which means actually the topology and the layer of switching, routing, etc. equipment on top of this topology. Providing a common support interface for European and global organizations. I've mentioned that earlier, sort of emulating that what we can do among the partners is sort of shown to a project as a whole. So we'll have to have a different approach to well, user support is what we classically call it, or common customer relations is what a more business environment would possibly call this. Finally, in defining the appropriate identity, service components, and trust models for remote access for virtual organizations. And I think, well, project progress, yeah. We have, in anticipation of that, work on the proposal started in 2007, at the end of 2007. Since September 2008, there have been partner meetings, partners in the consortium or in the project. And since December 2008, we've already started with the project management team meeting. We've had a week ago or so, we've had the 7th of those monthly meetings. We've also done a combined meeting of activity and task leaders. This is about 50 people in a room that sort of in a sort of mini kickoff looked at the full snapshot of all the activities so that there's a common awareness of what is being done. We've started a series of architecture workshops that look at the topology and the technology that we're using and at the estimated capacities needed and services needed. We've had 2 of those, and we'll have another one on the 7th and 8th of July. There are 2 events in the future that I would like to point to here. There's going to be a kickoff meeting of the project, an all hands meeting really on the 8th to the 10th of September. And there will be the official GN3 launch planned in Stockholm during the Swedish presidency on the 1st and the 2nd of December this year. And there's a project portal, and there is a public website. And here again is the vision statements summarized again for your perusal after this event. And that brings me to the end of my talk.
I want to thank Hans very much for his talk. I know he had a lot to fit in. I think he did a good job in giving a good view of the highlights. What I wanted to do, because we have Aphrodite to talk about the more technical, the research and service development of the project, I wanted to wait until both presentations were heard and then open the floor up to questions, because Aphrodite may well answer some of the questions some of you may have. But actually, before I ask you about Aphrodite, I did realise that I hadn't actually introduced myself, and I thought I'd better tell you who I am. I'm Melanie Pankhurst, and I'm on the programme committee for the TNC, which is why I'm standing here in front of you now. But I'm also the PR manager for Dante, and I lead the activity on joint dissemination and outreach, which basically means promotion and marketing and dissemination into Europe and beyond. So I'd like to introduce Aphrodite Savasti. She's going to explain the key focus of the services that Hans mentioned and how the research development and rollout of the services will be sort of structured and handled. Aphrodite is the Service and Infrastructure Development Coordinator at GÉANT, which is the Greek Research and Technology Network. She's been involved in the previous GÉANT project, coordinating bandwidth on demand activity. She is also on the standardization and liaison activity for Federica project, and is now activity leader for the multi-domain resources and services research activity, and that's the capacity she'll be talking to you now. So, thank you.
Thank you, Melanie. I have this talk which is following up Hans' generic introduction and is especially focusing on the service activities and the innovation aspects of the GN3 project. It's a pretty dense presentation, so I will stick to keywords, and if there are questions, please feel free to put them here in this session. We have most of my colleagues who are leading the activities in the room. And of course, we can also meet in the breaks for more details. So landscape for GÉANT3, in terms of the infrastructure, is quite familiar to most of us. So we have heterogeneous networks interconnected, and we have access infrastructures at the edges of the national research networks and the GÉANT backbone. So more or less, we have a known infrastructure environment on top of which the GÉANT2 project has developed a number of useful, interesting tools and prototypes for the management and leading to a service portfolio for a multi-domain environment. The idea now for GÉANT3 is to build on these existing results, to consolidate them, to reinforce them, and also put emphasis on community services on top of the infrastructure and the management and service portfolio. So the goals of the work plan, the overall goals, is to, first of all, provide and manage an advanced and cost-effective networking infrastructure, and also expand it, as we saw in Hans's presentation. Then to develop and support the portfolio of advanced multi-domain services on top of this infrastructure. And last but not least, to empower end users with the tools for mobile research and education, and also high-end users with utilities to exploit what we call the distributed infrastructure environment that the project is working upon. The project structure, as also present in Hans' presentation, is divided in the layers of the core, backbone, architecture, design, planning, and procuring, and building and operating activity, the multi-domain network service operations, and the end-user services in a federated environment. And complementing these service activities, we have parallel threads. The GÉANT, the research activity for future networks, which is complementing SA1. The GÉANT2 multi-domain resources and services activity, which is complementing SA2, and the enabling communities research activity, which is complementing SA3. Now we will dig into the details of each one of these activities for the project, starting with the GÉANT network architecture and design, planning, procuring, building, and operating. Long name for an activity. The idea here is to have a cost-saving approach, to adopt cutting-edge technology and also reliable services to migrate from the GÉANT2 to the GÉANT3 infrastructure. And what is the method to achieve that? First of all, there is preparation for network planning and procurement, which has to do with architectures, the requirements of our customers, the availability of fiber, technical evolution, and planning for future network element procurements. Of course, there are also topological and cost of ownership studies that will have started and will continue to contribute to this goal. This set of activities will lead into the procurement of the network elements. And at the same time, in parallel, the provisioning and operation of the existing services and infrastructure will continue seamlessly. In this environment, there is a combination of different roles for the Dante operations, communication, upgrade of services and the backbone capacity, operations, and enhancement of existing tools to carry out the operations. Moving on to the service, to the activity for network service operations, you have seen this service improvement life cycle also in Hans's presentation. It's very important for this activity, and the major goal here is to turn research and technology results adopted and inherited from GÉANT2 and other efforts globally into multi-domain services that are quick and efficient, robust, trustworthy, have high availability and performance. The methodology here is, first of all, to devise the life cycle management of the connectivity services portfolio, to implement and monitor these services, to define the operational procedures. Let's not forget that this includes multiple network operating centers of the network that are involved, security consultancy service, detection of and reaction to security incidents, and the tools that have already been in place and are under development will be further reinforced, and their development will be continued. The third service activity has to do with end-user services in a federated environment. Here we have two major areas. One has to do with end-user services, clearly defined use cases, and one has to do with meta-services, services which are used to allow end users to access other services in the GÉANT environment. So here we have a layered model where on top of the network, the NRNs agree and implement a trust environment with federated authorization and authentication. And on top of that, this service activity works on end-user services that are perceived by end users as the means to access resources and services between institutions and on their local environment. So the methodology here is has three parallel activities. One is the implementation of a PKI factory, policy management authority, repository for PKI routes, and the PKIs themselves. Pan-European roaming services and the authentication meta-service for this federation of networks, and the Pan-European web single sign-on and authorization meta-service with the use and evolution of the GÉANT framework, which was a very valuable result from GÉANT2. Now, if we keep in our minds these three main service activity areas, the corresponding ones in the research environment are the ones to follow. So if we keep in mind the backbone and GÉANT backbone development, procurement, planning, architecture, study activity, the service activity one, then here we have the corresponding research activity, which is called Future Network, Backbone Network Architecture and Operation. Here the idea is to bring into the GÉANT environment the innovation from emerging technologies which will enhance the existing portfolio of services and new architectural paradigms. And the results for this activity can be reused by the entire GÉANT3 community, so they will not only be useful for the GÉANT backbone itself, but can also be useful for the NRENs themselves when designing next generation networks and services. And of course, we are hoping that the studies that we will make and the requirements that we will collect in terms of architecture and basic functionality will influence the technical roadmaps of equipment suppliers, and for this reason, this activity will be seeking a high degree of engagement with equipment suppliers. So the topics here is, first of all, to study carrier class transport technologies like PBT and new functions for Ethernet operation and maintenance. Then to move one lower below with photonic switching, 100 gig testing. Then to study federated network architectures that have to do with how do you create virtual organizations for these architectures, how do you implement field line maintenance, and so on. And last but not least, the current potential uses of virtualization. What is the equipment capability for virtualization in a single and multi-domain environment? What is the method to create a single domain composing of resources from multiple domains using virtualization technologies? And of course, the business analysis of virtualization deployment. For this specific activity, interaction with equipment vendors and standard bodies is very crucial. Now, if we move to the area of multi-domain services, one level above the basic infrastructure, the research activity has as its major concept to create management, control, and service provisioning environment for the GÉANT and European NRNs in the lifetime of GÉANT3. First of all, we are working on an architecture for multi-domain management and services, the investigation specification for multi-domain workflows, research and progress on control planes, on cross-layer monitoring, on inter-domain security, and also the improvement, consolidation, optimization of the existing multi-domain tools that are used today in our community. The problem space here combines input from the GÉANT outcomes, operational requirements of the NRNs and the GÉANT backbone, technology evolutions, collaborations, and multi-domain peerings with other research networks around the world, the user community requirements, and of course the emerging standards. So it's quite a complex environment. The main areas here is, the main concept here is to try to combine the existing efforts so far to a vendor-independent service stratum for improved operations in the multi-domain European research and education environment. So what we want to have is a homogeneous management architecture in which all the tools that we have so far, which are more or less isolated, tools for monitoring, tools for circuit provisioning, tools for security and incident handling, are integrated and can interact to provide an improved experience to the operators and the users. Then we have to continue our work on hybrid network provisioning, then also advance the monitoring works from GÉANT and the persona framework, standardize more of its aspects, integrate it with a multi-domain management infrastructure, improve the trust in the tool and the environment and so on. Then there is a very interesting piece of planned work about, first of all, advancing the tools and the algorithms that we have investigated in GÉANT for incident and security threat detection, but also try to see if we can build a knowledge-based system in the multi-domain environment that will allow multi-domain coordinated incident handling among the European NRNs and the backbone of GÉANT. And last but not least, we would like to implement from a subset of the GÉANT and NRN existing infrastructure what we call a network factory. An infrastructure is slice, a layer independent of the production environment available for user demonstrations and use cases. The third area of research in GÉANT is at the user community level. It has to do with access to services to support collaborating communities, federated access to the resources, to the infrastructure, and a framework in which resources and services in different domains and operating at different layers can be composed and accessed by the user community. Here there is the important aspect of the life cycle of this activity is that it involves use cases and constant interaction with user communities. The tasks here are again in three areas: advancing the roaming developments, standardizing developed features, improving user identification at hotspots, for example, or implementing authenticated DHCP. Improvements and advancement in the identity federations, solve the existing problems in identity management systems, exploring next generation identity management systems like OpenID, for example, or prototype a framework for AI to be adopted by GÉANT services. The last task of this research activity has to do with a framework to define, discover, access, and combine network services to a service delivery platform addressed to NRN staff, operations people, e-sign service providers, and end users in a way in which the resources, the management services of the network infrastructure, and the end user services will be components and tools in the hands of the end user community for composable services and doing their day-to-day business. The service activities and the research activities in the GÉANT project have to work very closely with each other. There is a constant interaction between the groups. about requirements and additional features that the service activities would like to see, and also ideas and proposals from the research activities to enhance and improve what the service activities are up to. So this is a very important aspect in our project. It is quite new because as you could see from Hans's presentation, the groups and the amount of people contributing to these activities are really in large numbers. And it's a challenge for us to try to keep the operations people and the research people, the people who are bringing up the new ideas in a constant interaction loop so that we can get the best out of the project. And here is again the list of the names of the people who are contributing, who are leading the service and research activities in the GN3 project. I think everyone except for Marian Garcia is in the room. Please feel free to ask specific questions for what I just presented or generic ones for the presentation as a whole. Thank you.
Well, thanks to Aphrodite for that. And I think if we have perhaps Hans and Aphrodite can both be here to take questions, or as Aphrodite said, anybody who's involved in the project that is relevant to answer. Has anyone got any questions at all from the floor?
Hello, good morning. Gioacchino Buscemi from European Space Agency. I see a big change in your concept. You are moving to a service delivery concept instead of a research and development activity. So it means that you are going to provide an SLA to your customer in the future, and so you will act, you or Dante will act as the first provider, one point of contact towards the other NRNs. Thanks.
As you saw, this was in the list of challenges. Yeah.
Only one.
It's very well understood, and ESA is not the only one organization that is asking this question. This community has a sort of a subsidiarity principle, and they're the customers nationally. Yeah. But I think in the project we recognize that we have to build a body built from the members that actually acts as a virtual sales force somehow. Otherwise, we are bound to be inefficient. Yeah.
Last year we had a session, a panel session, if you may remember, called Good, Bad, Ugly. So back then I tried to be the bad guy, now I try to be the ugly guy. So back then we had we noticed three themes in there. So one theme was the Global Lab, the Integrated Facility, and the place of GN3 and GN2 in there. Another one was cross-border dark fiber, and the third item we noticed was about the research and so on. I leave the research alone. Can't hear anything.
Switch on the microphone.
You want to come up here?
Okay, my name is still Kees de Laat. So last year, I'm reminding you, we had a panel session, the good, the bad, and the ugly. Last year I tried to be the bad guy, now I try to be the ugly guy. So in that panel session we noticed three themes. So one theme was Global Lab, the Integrated Facility, and the place of GN2 and GN3 in that, and the way it interacts with that. The second thing was cross-border dark fiber, and how GN2 or GN3 may take the opportunities there and participate in that and lead that, so look at the opportunities of dark fibers. And third thing was about research and the place of research among NRANs and associated universities. So the third theme I would like to leave alone now, but I did not hear the G word anywhere in your talk. So how will GN3 interact with GLIF, with open exchanges? Your global map did not show, for example, any of the worldwide connectivity which is there in the GLIF community, which you would be able to tap on and so on. So how are you going to participate and work with the GLIF communities and the open exchanges, which just like the internet exchanges are the seeds for getting global connectivity. And the other thing is, of course, the dark fiber and the dark fiber opportunities which different NRENs are creating, which gives actually an enormous scalability boost to our networks. So these are all the questions.
Okay. You're not really good at being bad or ugly, but but you're a bit difficult. I think I'll answer the second one first, and then the cross-border fiber. We have actually, with a lot of enthusiasm, looked into that, and a bit blue-eyedly looked into that in GÉANT2, because I don't know whether I get my map quickly back, but you see that all these red road networks or route networks that are built up nationally, and there's not very much needed to interconnect them. Yeah. We've hit actually administrative difficulties. In some cases, there are areas where it's very easy and attractive. Yeah. For example, GÉANT delivers us a bit of service to Ridge Island from London. Yeah. So we do use it. Yeah. There is an optimization problem. If you build a topology, you agree on a reasonable density of meshing, then you sort of have to have your blueprint, and then you can optimize it with your procurements or with your sourcing of resources. If you do not do that, I mean, of course this is not a footprint that has to be there forever. It can be adapted, but it can be adapted by sort of common project will, and not sort of by individual opportunities being taken, if you are in a financial environment that is co-financed by everybody. So you cannot just add bits and pieces here and there. You have to make a common decision to change the topology. Yeah? So the plan of GN3 is to actually include, where possible, NREN-owned connectivity, yeah? Where possible and economically sensible, of course, not just because it looks nice on the map, but because it would save us money to do something else or to do more. Yeah? If you're a fiber operator yourself, you will want to look at having as many wavelengths on your infrastructure as possible. And that sets a limit, it sort of sets that balances with the wish to be extremely fine-grained. Yeah? Yeah, the more possibilities you have, the less you have, the more expensive per wavelength your infrastructure gives. So this is it's an interesting and a nice optimization problem. And I believe the outcome of that will be that there will be more than now NREN provided resource. Yeah. There is also a procurement issue. We are publicly procuring, and we have an issue to procure from our partners. Yeah. So we'll have to find a way around that. But there are a couple of wise people that are going to be assembled to exactly look at this and at operational issues of cross-border fiber. They're also there. They bring us back into the time of the monopoly telcos with half circuits that meet on the border, which is not really very nice situation operationally. We'd like a single, for one wavelength, we would like a single responsibility. Yeah. And so that's sort of what I'd like to say to the CBF situation. looks very convincing when you look at the map and says, oh, just these little things. But there are other considerations that we have to really balance nicely and look what is best for all of us together. That was only one. The glyph thing is that we work for research and education. I mean, what I presented here was what the project itself does. Yeah? Obviously, there are many entities that provide worldwide resources. Yeah? GÉANT is willing to collaborate with anybody that does research and education traffic. Yeah? I should also say that the nodes, the lambda exchanges or circuit exchanges are not unique. I mean, actually any GÉANT pop on the fiber cloud can play that role. We can pick up circuit services on any node. We have, again, an operational issue where the views, or maybe not, they're not unanimous views, but the prevailing views in GÉANT are that splitting into many individual operating entities is not necessarily optimal, and that we'd rather want a large predefined operational environment, and that's my main argument for dealing with the glyph. Yeah. Obviously it's there, it has a nice connectivity map, yeah. And we do a lot of services that end up in Europe actually go through the glyph. Workshop number 3 will actually, which is in a couple of days' time, will actually assess that and see what the effect of it is. Yeah. So.
My name is Vasilis Margaris, and I'm the chairman of the National Research and Education Networking Policy Committee that does policy coordination and really looks into the issues that were raised before by Kes. On the glyph stuff, I mean, I think that Hans already replied. I mean, it is a complementary type of activity. We look at it, and I believe we're right, maybe wrong, but the way we look at it, I look at it is some more physical connectivity available, or some very nicely and attractive in terms of price and so forth, which we may not use. It's a matter of optimization and a matter of agreements and between the glyph exchange operators and our operating teams. So I don't see too much conflict, if you wish, or any conflict between what the glyph does at the physical layer and what we do in any other layers. Now, I would like to stress a bit the cross-border fiber issue, because this has been promoted and by us also and by the Commission, and everybody looks at it as something like a paradigm shift. Our experience so far, and I may be wrong, I mean, Hans has dealt with that, matter many years now. Our operational experience so far, at least the way I look at it, was not always positive. And let me explain to you what I see as having been done in the past. We distinguish 2 types of cross-border fibers. One is type A, I'll come to that later, and the other one is type B. Type B is wavelengths or circuits or whatever you want to call it that are provisioned specifically for a project. So if there is an option, be it glyph, be it lambda provided by 2 neighboring end-runs or 3 consecutive end-runs in one after another, fine, we take it. It creates a nice and cost-effective circuit, and of course, you know, there are many issues there, but finally, you know, it can be done. And we do have problems of how to make that look into a whole network. Take, for instance, the LHCOPN. It's a whole network. We're not providing just lines and let the end user provision its network. This is one option, but the other option that is attractive about GÉANT is that we try to give a manageable network, not just lines. So if we can do that, and we try very desperate to do it, and Aphrodite will be instrumental in that, and also Anne Hardin in her multi-domain provisioning approach and so forth, fine, it will be perfect. That's for type B. For type A, it is fiber given, provided to GÉANT by end-runs, neighboring end-runs. for general use, which means that we need, if we're going to get any type A fiber, and to my knowledge, there has been no type A fiber implemented so far. Am I correct, Hans?
Type A services are actually the line to Dublin from London is.
Okay, so there is only, in the UK, okay, and between UK and Ireland.
Well,
Yeah,
internationally.
okay. But we tried this option in some other cases, and we had some problems having to do with compatibility, operational issues, national issues, all sorts of things. And in my view, it is also a quite great technical challenge of if two NRENs can provide dark fiber pairs and stitch them together, that will be fine. But if we're going to get 2 or 3 wavelengths from one NREN, 2 or 3 wavelengths from another NREN, stitch them together, it is possible, but it does not give us at least what we preached as the flexibility of being able to quasi-dynamically set up and disconnect the circuits, do things like that need some more cohesive type of approach. And dark fiber, we're preaching dark fiber. Now, if we from preaching dark fiber, we went down to getting lambdas from NRENs, it may be an attractive option in terms of economics, but it may also be a step backwards from what we preached in terms of dark fiber footprint around Europe. So if there are NRENs that can provide dark fiber pairs to us, that will be fine, perfect. It will be the perfect solution. This is a personal view. Now, take that against what is happening now, and NRENs willing to give a few lambdas. Fine, this is fine for project, this is fine for specific requirements. For general use, we'll have to be a bit more careful.
Thank you. Have we any other questions at all? That's on. Oh, sorry.
I'm Kees Neggers. I'm Managing Director of SurfNet in the Netherlands, and I'm also chairing the GLIF Corporation. I would like to react to both what Hans said and Vasilis said. First of all, it looks like everything is very complicated if you listen to Hans and to Vasilis. My experience is it's not complicated, and GLIF approach has shown that. And the reason is simply because the bottom line is to create neutral exchange points where people asynchronously can meet and very successfully make multi-domain end-to-end connections. And in the technical annex of the GN3 project, GLIF and open exchanges are explicitly mentioned as one of the tools that GN3 is going to use to make the world less complex. And I'm very disappointed that this is not mentioned in your presentation. And I'm also disappointed in you, Vasilis, that you talk about us as being Dante and the NREN PC. Us is all the NRENs and Dante and Terena and everybody together. And that's what we have to create together in Europe.
If we let Hans.
You see that there are various opinions in the project.
I think there may be some agreeing to disagree at the moment on that, but debate can continue, and if people want to continue debate, I'm sure that there are people in the project and in SurfNet are happy to continue that offline. But I think for now I'm going to have to say thank you very much to Hans and Afroditi, and thank you for the discussion. Thanks for that, and thanks for always good to have a discussion. But we need to move on now to Steve, who Steve Cotters from ESNet is the department head of the U.S. Department of Energy's Energy Science Network, so that's why they call it ESNet, because it's not such a mouthful. Steve used to manage Google's network deployments in Europe, Middle East and Africa, and he also was at Internet 2, deploying and managing their hybrid network infrastructure. Steve's going to talk about ESNet's new hybrid network architecture and how it's going to meet future needs of virtual collaborators and science. Thank you, Steve.
Thank you, Melanie, and thank you for this opportunity to talk about what we're doing at ESNet. Let's get this on here. All right, I'll start with giving a quick overview of ESNet, which is short for the Energy Sciences Network. We're within the Department of Energy's Office of Science, and the Office of Science is one of the largest supporters of basic research of physical sciences in the U.S. We directly support the researchers and scientists and postdocs that are funded by the DOE, either at the laboratories or universities and other federal agencies. ESNet was established in 1985 to provide the Department of Energy's networking infrastructure in support of the activities at the Office of Science. And we've been enabling the scientific discovery ever since those early days of the internet. ESNet's sole purpose is to support the research and the researchers at the Department of Energy's Office of Science, and the needs of these researchers are different from those of commercial users, obviously. So we have to regularly explore their needs and their plans and processes. And we do this in order to understand the data characteristics of the new instruments that are coming online in the facilities, how this data is going to be used, analyzed, how much is going to be generated, and where it needs to go. We also look at the future process, how this data is going to be analyzed, how this is going to change as these new facilities come online, and how this is going to evolve over the next 5 to 10 years. We do this through a series of workshops that we conduct. There are 6 programs within the Department of Energy, and we rotate through each of them, doing 2 workshops a year on network requirements, where we really dig down deep with the researchers and the networking folks at these facilities to really understand what their needs are, so that we can help understand not just what their historical needs are, but where they're going with the network traffic. So as ESNet is driven by the science and the scientists, we've come to understand that there's a direct correlation between scientific productivity and the ease of access to large data sets. We're seeing that scientific data sets are growing exponentially, and it's beginning to outstrip our ability to analyze and store this data. We're also seeing simulation systems and the devices gathering this data, growing along the lines of Moore's Law. So we don't see that abating anytime soon. These are just a couple examples of the large data sets that are being used by the different activities within the Department of Energy's Office of Science, and these are quite significant. Everyone's pretty familiar with the high energy physics data requirements. We're also seeing the climate community's data needs growing significantly at even a faster rate than what the high energy physics community's been growing. So the needs are significant. So that brings us to the challenges that we faced at ESNet. Just like GÉANT, we've had to understand how we can scale economically to meet these demands so we can handle this exponential growth. ESNet's average year-over-year growth since 1990 has been about 72%. If you plot this on a logarithmic scale, you can see, actually quite surprisingly, there's been a pretty consistent growth rate. But if you extrapolate this out to the next level, you see that we hit 10 petabytes a month in the July 2010 timeframe. So that's roughly 30 gigabits sustained. So that's still considerable growth, and we've seen our traffic increase by a factor of 10 roughly every 4 years. So we don't see that abating, and in fact, we've seen that growth accelerating in the last couple years above the historical growth rate. Another challenge that we've been facing is, as you guys know quite well, is that collaboration is becoming more and more international. We need to be able to get these data sets across multiple domains, across long distances, and that presents its own set of challenges. And the last challenge that we notice is that there's been a fundamental shift in the traffic patterns. Pre-2005, most of our network traffic was similar to commercial traffic. millions of small flows, email, web browsings, video conferencing, small data sets moving back and forth. Since 2005, what we've seen with the large scientific instruments coming online and the supercomputers with petaflops of computing power, the top 1,000 flows have begun to dominate the network. And today, it represents about 80 to 90% of the total traffic going across the ESNet network. So that change in the network characteristic led us to our latest network, which is a hybrid infrastructure that combines both packet and circuit switching to handle these massive amounts of data. It gives us a network that combines the flexibility and resiliency of IP along with the deterministic high-speed capability of the circuit switch infrastructure. And we did this using commercially available technologies and created two logically separate networks. One is a separate IP network at 10 gigabits, which still handles the regular operational traffic between the labs. And then we built a second network using more cost-effective layer 2 and 3 switches as a circuit switch, virtual circuit type core network, where we will continue to expand this with multiple 10 gigabit circuits as the needs arise. No talk about networks is complete without a map, and here is the ESNet network. You have right now in the black lines the IP network, which connects the 10 Office of Science sites. And then we have an additional 40 or so dual-use or multi-use lab facilities where DOE-funded research is ongoing, and those are connected to the network. As you can see here, we also have, in addition to the underlying layer 1 network infrastructure that we share with Internet 2 on a dedicated optical fiber pair and dedicated optical equipment that just has ESNet and Internet 2 wavelengths on it, we also get some diverse networking from waves that we purchase from National Lambda Rail in the US, and we use that primarily as backup in case we run into problems with the existing infrastructure, which quite fortunately we've not had to use. The shared Internet 2 infrastructure has been very reliable, and we're very pleased with that. We also have extensive peering both with the Research and Education Network and the commercial network at the various peering points around the US. As you can see here, it's pretty extensive. There are over 100 networks that ESNet peers with. And then lastly, on top of that network infrastructure, we built that second network, which is the Science Data Network. As you can see here, it's 10 gigabits on the west, on the east, and going out from Chicago to Denver. It's 20 gigabits, and we have the ability to scale that up as the network demands grow, and we will be adding additional wavelengths here quite soon because we've already begun to fill up the Science Data Network in the east with reservations. So the key components tying these two networks together are the ESNet developed what we call OSCARs, which is On-Demand Secure Circuits and Advanced Reservation System. This protocol spans both the networks and allows scientists to request dedicated bandwidth to move their large data sets or to tie into the scientific facilities. We also have aggressively deployed perf sonar across the network infrastructure, both in the backbone and at the sites, to help us with gathering and sharing network performance information as well as facilitating troubleshooting. And we found it very effective in helping us and the sites identify problem areas in the network and resolve them quickly. OSCARs, which ESNet has been an active member in the DICE collaboration, is compatible with the other on-demand dynamic protocols through the IDC. And the services that OSCARs provides to the ESNet community is listed here includes guaranteed bandwidth resiliency. So researchers, particularly, we've seen this used by the LAC Tier 1s to the Tier 2s. They want to reserve specific bandwidth with a primary and backup path and have that available to switch over without problem. We also use Oscar to provide traffic isolation for non-standard transport mechanisms. Internally, we use it for traffic engineering to meet specific requirements, whether we want to bypass congested links or use higher capacity, low latency paths. Also provides secure connections, and by secure we mean between the edges of the network boundary. And we've worked very closely as part of the DICE collaboration to ensure that this works across multiple domains. And this is helpful for both the labs and institutions that we connect with. The Oscar's software, this is version .5. It came out first quarter 09, and you can see we have Oscar's, the authentication, authorization, and notification broker. It's architected this way, and we are working on the next release, which we're targeting for the third quarter, where we take the Oscar's code and we break out the path computation engine, path setup from the core network. And the reason that we're wanting to move to a more modular type of code as we productionalize this software is so that we can pull out different components of the software and stick in potentially more useful or better modules. And here is an example. If we used a different path computation engine and we develop, say someone comes up with one that is more effective, or there are multiple ones and we want to daisy chain these, we can do that with the software. So we're moving to that as the next release of the Oscar's protocol. So the theme of this session is about change, and even though we just completed the build out of the Science Data Network in November, and then went and upgraded the metropolitan networks this first quarter, there's no rest for the weary, and we're now looking at getting about just shy of $70 million as part of the stimulus funding for the Obama administration has to roll out an advanced networking initiative. And there's 3 components to this, and we've been actively planning and working on this since probably about the February-March timeframe. And the 3 components are to build out a prototype wide area network, not only to address our growing data needs, because we're not really there yet with the need for 100 gigabit, but the administration viewed it as an important, mission that we could be given, is to help accelerate the development of these 100 gigabit technologies. They were concerned about the downturn in the economic environment such that innovation may slow down or be put on hold because of the financial constraints that a lot of the companies were under. So this is one activity that we are being tasked with, is helping accelerate this into the wide area network and put something out there that could be either pre-standard or early standards compliant. We're also going to be tasked with building out a testbed facility for researchers and industry. So this will go on top of the new network infrastructure. And then, as part of the $70 million, $5 million has been set aside for research grants to deliver near-term technology transfer to the production network. So if you look at the network map, here we have both the IP and the Science Data Network. On top of that, we are looking to build a 100 gigabit wide area prototype network. This will be in addition to the existing production network. And the idea is to tie together the DOE supercomputing centers The one supercomputer center is at the NERSC facility in Oakland as part of Lawrence Berkeley National Lab. We also need to build out to Argonne outside Chicago, and then down to Oak Ridge National Lab outside Nashville, Tennessee. And then the fourth component that we're going to build out to is the Manland International Exchange Point in New York City. In addition to building out the wide area, we're also going to be upgrading the metropolitan networks in the Bay Area. We'll be building it out from our backbone network node in Sunnyvale out to the facility in Oakland. In Chicago, we'll be building along the same path that we have the current Chicago Metro network, and in what we call the Atlanta Man, we'll be building out from Oak Ridge to the backbone network. And then we'll also be doing a small ring in New York City between the backbone node in New York to 32 Avenue of the Americas, where the Manland facility is located. And in addition to those first two components, we talked about building out a network test bed. We are currently in the process of architecting that right now based on some of the early research proposals that DOE is considering funding. So we're trying to match up the capabilities of the testbed architecture with those early research projects. It'll probably include a combination of 10 gigabit waves. It'll provide access to the 100 gigabit infrastructure, and we're going to actively pursue getting some dark fiber as well to provide a facility to do some layer 1 research. As I said, the testbed will consist of network devices, components. It's going to be available not just for network research, but also applications and middleware. It'll be available not just to the DOE community, but also to industry. DOE has had a very successful program with the supercomputers, where they make the supercomputing facilities available to not just researchers, but commercial entities, and they do a peer review of the proposals and allocate those resources to the best research proposals, and the same thing will happen with this test bed. It'll look to support multi-layer dynamic technologies, and some of the things we'll be looking at is the ability to classify large bulk flows and move them between the IP infrastructure to dedicated virtual circuit infrastructure, as well as helping to facilitate technology transfer between research activities and the production network. So in summary, we've kind of worked our way through a lot of challenges and developed a new ESNet4 infrastructure, and right quickly on the heels of that is now we're turning our attention to building out a 100 gigabit infrastructure. And so it gives us a bit of a dilemma here. We built that infrastructure out thinking that we would have 3-4 years of using it, learning how to manage dynamic virtual circuits using Oscars, and now we're going to throw out significantly more capacity, and so we're kind of rethinking our network strategy and kind of the role for Oscars. We still believe that it has a role in the network, whether it's through kind of network engineering or providing advanced reservations and end-to-end quality of service guarantees to network researchers. But we're going to kind of keep an open mind about this, and the prototype network is going to give us several years of playing with that infrastructure to see how it can best serve the community. I think that with these two networks, both the production and the prototype network, we're going to have some opportunities. We're going to enhance the ability to carry out distributed science at an unprecedented scale globally, but also there's the opportunity for unforeseen commercial applications that will hopefully encourage through use of the test bed that may provide, some innovative, applications and uses. Just as the high energy physics helped spur, the development of the internet, we hope that this can do the same sort of thing. So, and that is the conclusion of my talk. So. You want to take any questions?
Well, yeah, I want to thank Steve for his talk, and I wonder if there's any questions from the floor at the moment before I launch into mine. I was particularly interested in the 70 million research sort of grant from ARAS. I don't know if I heard what ARR or AS is it stands for?
That's the American Recovery, I'm not sure, I forget what the other.
I'll Google it. But then the other thing is, does that mean you actually have to employ more people to do the research? So there's an expanding?
Yes, yeah, part of, some of the rules behind the stimulus funding is to create jobs. So it comes with a whole list of reporting requirements and metrics that are significantly different from our normal funding. So it's got a limited time frame in which we have to implement this. It's supposed to be, quick. And we also have to track not just the jobs that we create, but also the jobs that are created by the spending of the money. So, the equipment vendors and carriers that we use will also have to report up to us the jobs that are created or saved by the spending.
So is it like a different project created, or is it still run by ESNET? Or do you create a different project? Project leaders to run with that initiative?
Well, it'll be led and managed by us. We'll be hiring project managers to work within that, because we still have to run the regular production network, and that's what we're staffed for. But we'll be adding quite a few headcount to our existing staff to do that.
It's an interesting concept.
Great.
And very good for ESNET. Oh, sorry. Vasilis.
Yes, my question has to do with dynamic circuit provisioning. You are, I guess, at this point in a position to know what are the heavy users, high energy physics people and your labs in terms of dynamic circuit requirements. What is your experience to that one? Two, do you have any comments on joint trials you did with our own teams, with the Autobahn, interworking with DCN and that stuff? I mean, is there any feedback you want to give us on that?
Sure. As far as the dynamic provisioning, we've had it in production in the ESNet network for a year. We do it at layer 2 and 3. We haven't gone down to layer 1. We were going to look at that over the next several years before the stimulus funding came, and now putting out a 100 gigabit network. But we anticipate that the virtual circuits at layer 2 and 3 will still be pretty popular. Last year, I believe we had about almost 3,800 virtual circuits created across the network infrastructure. A lot of them were done automatically through integration with TerraPass and some of those other protocols. We plan to continue to be closely working with the members of the DICE group on the integration of the dynamic circuits, and I think that collaboration has been very positive. It's been very helpful to us, ensuring that we are compatible across multiple domains. And I think as more and more traffic crosses from Europe to the U.S. and back again, as the LAC turns up, and eventually ITER and these other facilities, the cross-domain work that we're doing is going to be very important. So, to answer your question? Okay, thanks. All right, thank you.
Well, if that's it, then I'd like to thank all our speakers. And thank you for attending this session. And just before you go, I just want to do a plug for some of the other GÉANT things. Two of the speakers in this session were part of the GÉANT distributed workshop, and there's a number of other presentations that will present GÉANT-led activities throughout the programme. And also there'll be a demonstration at 2:15 today of the Astra project, which is how the networks help to recreate sounds of an ancient instrument, and that's very interesting and very different. There's also a demo on CNIS, the Common Network Information System, which will be out in the demo area as well. And tonight there's a Birds of a Feather session on Meet the Neighbours, extending the geographic region of Europe, and that's 7 o'clock till 8:30. So thank you very much for your time.